Good day everyone, I am Marlon Macarini and today I am about to discuss constant of integration C. Is one of the example problem of constant of integration. The problem is find the equation describing the motion of an object moving along a straight line when the acceleration is constantly 2 meter per second squared, when the velocity at time 3 second is 10 meter per second, and when the object has traveled 70 meters from the origin at time 5 seconds. The given of the problem are the acceleration, which is the 2 meter per second squared, the velocity, which is 10 meter per second at time 3 seconds, and the travel distance of the object, which is 70 meter at time 5 seconds. As we all know, acceleration is equals to derivatives of velocity in respect to derivative of time. To get the formula of velocity, we will now cross multiply the acceleration into the derivative of time to get. So this will become dv equals to a dt. Then to get the formula of the velocity, we will use the integration process. We will now integrate the dv and the a dt. So this will become v equals to integration a dt. Then the acceleration is a constant number, so we will not include this into integration process. So this will become b a integration dt. This formula, we will now use this formula to get the value of velocity or the equation of velocity. We just need to use the acceleration, then we will get the equation of the velocity. So by using the acceleration, which is 2 meter per second squared, we will now have v is equals to 2 integration dt. Now by this, the integration of dt is equals to t plus c, because there is no constant number, or there is no exponential number of the t. So we will now get v equals to 2 t plus c. Now we now have the equation of velocity, but the problem is we still don't know what's the value of the c, which is the constant of integration c. So to get the constant of integration c, we will use the velocity, which is the 10 meter per second at time 3 seconds. So by this, we will use the substitution. So we have the 10 meters as b is equals to 2 times at 3 seconds plus c. So we'll equate this. 10 is equals to 2 times 3 is equals to 6 plus c. So c is equals to 10 minus 6. So c is equals to 4. Now we have the value of c. So we can substitute the value of c into our original equation of the velocity. So we now have the equation of velocity. Final equation of velocity, which is v is equals to 2t plus the value of c, which is 4. Now we have now the value of the velocity. Then our second problem is the original equation of the motion. So as we all know, to get the original value of the motion, we will use this formula. We will find first the equation of the motion. So equation of the motion, which is s, is equals to velocity integration dt. This come from velocity is equals to ds over in respect to derivatives of time. We just cross multiply this to get this equation. Then we will substitute again. We will repeat the process of the last derivatives. So we have now the value of velocity, which is this equation, the 2t plus 4. So s is equals to v dt. So we will integrate this. S is equals to v integration dt. And substitute the value of velocity, which is the 2t plus 4. So s is equals to 2 integration of 2t plus 4 dt. Then so by this we will get the value of then the 2 number is a constant, so we will not include this into the integration process. So this will become 2 integration of t plus 4 dt. Then this will become 2 times t squared over 2 plus 4t plus c. So cancel out the 2. This will become t squared plus 4t plus c. So we will now have the equation of the motion, but we still don't know what the value of the c. So we will substitute the travel distance of the object, which is in the given is 70 meters at time 5 seconds. So we will just substitute the 70 meters and 5 seconds into the equation of the motion. So this will become 70 is equals to 5 squared plus 4 times 5 plus c. So 70 is equals to 5 squared is 25 Then 5 times 4 is 20 plus c. 70 is equals to 25 plus 20 is 45 plus c. So 70 minus 45 is equals to c. So RC now is equals to 25. We now have the value of the c, which is the constant of integration c. So we will just substitute this c into the original equation of the motion, which is t squared plus 4t plus c. So our equation of the equation of the motion is t squared plus 4t plus 25, which is the c. And there you go. We are now finished.